Okay, so we're asked once again to define electrical resistance. Now this is very common, as you probably know, because I've asked you like 4 times in the last 2 booklets. Right, the answer that you need to give is that you understand that resistance is equal to the ratio of the potential difference to the current through a resistor. Okay, and there are 3 elements here, or 3 ideas that you need to emphasize. So we've got the fact that it's potential difference, so to avoid voltage and EMF, potential difference, the ratio of potential difference to current through a resistor. And you can always add a little you can always add R equals V over I to emphasize your idea, okay? I never want anyone to get that wrong again. Right, question number 2. This is now a numerical question. You have a heating coil made of a wire of diameter, so you can already see, this is a question about resistivity. And we're getting diameter instead of radius. So there's something to think about there. Anyway, the diameter of this wire is 3.5 times 10 to the minus 4. The heater dissipates 980 watts when connected to a 230 volt supply. The material of the wire has a resistivity of 1.3 times 10 to the minus 6 ohm meters at the working temperature of the heater. Okay, so calculate the resistance of the heating oil at normal working temperature. Now, we don't have the length, so we can't use the resistivity equation, but we do have power. And we have power and we have voltage. So if we use P equals V squared over R, and you substitute the values all in, and you should get 54 ohms. Nice and easy. Now, from the resistance, we're asked to find the length. So now we do need to use the resistivity equation. Resistance equals resistivity L over A. But careful, because we're not given the radius, we're given the diameter. So we have to do something there. So if we substitute all our values in, we have 54 ohms is the resistance. The resistivity is 1.3 times 10 to the minus 6. L over area. Now what's the radius? 3.5 times 10 to the minus 4 divided by 2 square pi. Okay, so if we rearrange this, we get rid of this. Okay, I can draw it in here somewhere. We rearrange it and we end up with 54 times 3.5 times 10 to the 4 over 2 squared pi divided by 1.3 times 10 to the minus 6, and that should give us the length. The answer that you should get is 3.99, which is approximately 4 meters. Okay, so this one's not worth thinking about too much. So you have a resistor, 3 resistors, which you need to wire up so that you can have either P, 2P or 3P. So if you do this one, if you put a switch here, then this one will give you the option of having 1 resistor dissipating power P, and then if you put this circuit like this, then you have all 3 options. Why? Well, if we close this one here so that it's like so, then this resistor will work. But if we open it again and we close this one, then now you've got 2 resistors, 1, 2, so you've got 2 P's, okay? And if we close all 3 of them, we now have 3, 1, 2, 3 P's. There are many different ways of wiring up. This is just one possible answer.